Hi, everyone. So these are your notes for Unit 5, Quadratics. Number 1, factoring. So remember, for factoring, it's like a number puzzle. We need two numbers that multiply to negative 18, but add to negative 3. And because I have a leading coefficient of 1, I know that it's going to be z times z. There's no other combination that gets me to z squared. So for 18, it could be 3 and 6, 9 and 2, or 18 and 1. Now, because I have a leading coefficient of 1, I know that I can just look at these three combinations and examine them as is. In other words, no combination of 18 and 1 will ever get me to 3. Cross it off. No combination of 9 and 2 will get me to 3. 9 and 2 could get me to 7 or 11. Similarly, 18 and 1, I could get to 19 or 17. So 3 and 6 will work. Now they have to multiply to negative 18. So either this one's negative or this one's negative. So I look at the middle term. If my middle term is negative, the larger term needs to be negative, the bigger is positive. To check my answer, let's check. Inner plus outer needs to equal middle. The inner is 3z, the outer is negative 6z, and it gets me what I need, which is negative 3z. So that's my final answer. Now for number 2, it's also a factoring question, but if you'll notice, I have a leading coefficient of 5. So in this case, it's 5z times z. Nice thing is 5 is prime, so I know it has to be that combination. Now 8 could be 2 times 4 or 8 times 1. So which combination should we start with? Well, let's use number sense again. Let's think about 8 and 1. If I put an 8 here and a 1 here, without even writing everything out we did on this side, my inner would be 1z. My outer is 40. That's way too big. What if I switched the 1 and the 8? Now, inner is 8, outer is 5, which does not get me to 14. So 8 and 1, that's out. Let's try 2 and 4. So should we put the 2 here or the 4 here? Choices. Well, let's try, I'm going to do it wrong on purpose just to show you how you know if it's right or wrong. Let's try putting the 4 here and the 2 here. And let's check. Inner plus outer. Inner gives me 2z. Outer gives me 20z. But I need 14. No combination of 2 and 20 can get me there, so it's out. So let's switch. That didn't work. Let's switch the 2 and the 4. So 4 here, 2 here, and now let's check. Inner is 4z, outer 10z, and I need a positive 14. So let's look at our sign values. It needs to multiply to positive, so either they're both positive or both negative, because positive times positive is positive, so it's negative times negative. So I look at my middle term, it's positive, therefore it's going to be a positive 4 and a positive 10, positive 4, positive 2. So my inner is positive 4z, outer positive 10, adds to 14, and I'm good. Factoring, I know, is a sticking point for some of us, so we will have some additional factoring practice for our next class. Okay, let's get into solving. So why do we learn to factor? Well, we need to factor to be able to solve. So step 1, factor. So I have my double sets of parentheses. So w squared, that's just w times w. That's nice. Possibilities for 14. We've got, I don't really have space up here, so I'll write it over here. We can be 2 times 7 or 14 times 1. Which one could get me to my -5 middle term? Well, definitely not 14 and 1, but 2 and 7 can. So ask yourself, they have to multiply to be negative. Therefore, either the 2 is negative or the 7 is negative. But they have to add to -5. So that means that the bigger term is negative, the smaller is positive. Now, if I check that, my inner value would be positive 2w, outer value, negative 7w. So, let's just do that for our notes purposes. Inner is 2w, outer is negative 7w, and when I add those, I get -5, which is what I needed. Okay? So if you want to see this, go ahead and rewind, but just to keep the notes clean, I'm going to only include what's factored. Now, common mistake people make here, they say, oh, look, w equals 2 and w equals -7. That's not true. Remember, there is a times in between these. This term times this term equals 0. Well, what does that mean in terms of solving? That means if w plus 2 equals 0, if this term equals 0, the whole thing equals 0. Or if w minus 7 equals 0, this whole thing equals 0. So what two numbers would that be? That would be -2 and a +7. And I believe in Alex, they want your answers separated with a comma, so you would type in -2, 7. Okay. Number 4, same directions, same type of question, but notice this is not ready to solve yet. First, we need one side equal to 0. So, let's make a note. Equation has to equal 0 before we can factor. Okay, so let's make that happen first. Let's add 11w to both sides. So that's gone. So now I have 5w squared plus 11w plus 2 equals 0. Okay, we've now factored 3 times together. Go ahead and click pause if you feel confident in factoring this yourself. If not, just continue with me. Okay, let's start. 5 is prime, so I know it has to be 5w times w. 2 is also prime. That's nice. So either there's a 1 here and a 2 here, or vice versa. So let's try 1 and 2. Let's check. Inner plus outer. So inner would give me a positive 1w. Actually, let's not say positive or negative yet. Let's just say 1w. Outer would be 10w. And I need 11w. Well, positive, positive, so I know either they're both positive or both negative. Well, if I need a positive 11, they're both going to be positive. So, plus, plus. So I'm just going to erase this to keep our work clear. Feel free to leave it on your papers. So, now from here, the step is the same as it was in number 3. We're going to set 5w plus 1 equal to 0 and w plus 2 equal to 0 minus 1. Divide by 5. W equals negative 1/5. And W equals negative 2. So in ALEKS, my final answer, negative 1/5, comma, negative 2. Okay, number 5. Write the quadratic equation whose roots are negative 1 and 5 and whose leading coefficient is 4. So now, instead of giving you the equation and asking you to solve, I'm giving you the solutions. I'm telling you x equals negative 1 and x equals 5. So here, when I say whose roots are negative 1 and 5, that means I'm telling you that x equals negative 1 and x equals 5. So ask yourself, what factor did those two come from? Well, that came from x plus 1. That came from x minus 5. And the only piece of information I haven't used yet is leading coefficient of 4. So there it is. 4 times x plus 1 times x minus 5. Now, am I done? Well, the question asks for a quadratic equation. Quadratic equation is in the form of f of x equals ax squared plus bx plus c. This does not look like that. So we are not done. We need to multiply this. So you actually have two choices, and I'm going to slide this over so I have room for both choices. Well, I will attempt to. I might just need to rewrite it. So we had x plus 1, x minus 5. Okay. Option 1, multiply the 4 into one of the terms. This is key. You are not multiplying 4 into every term. So if you want to start with the 4, it's only being multiplied into that first factor. So I would have 4x plus 4 times x minus 5. Now I FOIL. 4x times x is 4x squared. 4x times negative 5, 4 times x, and 4 times negative 5. When I combine like terms, I get my final answer. Option 2, let's rewrite the equation. Okay, option 2 is to multiply your factors first, combine like terms, and then multiply by 4. What would that look like? So the 4 stays. X times x is x squared minus 5x plus 1x minus 5. Combine like terms. Now distribute the 4. 4 times x squared, 4 times negative 4, and 4 times negative 5. Notice we got the same answer. So this is completely up to you. Option A, option B, they both work. Number 6, solve x squared equals 12, where x is a real number. So hopefully you remember from Algebra 2 that the inverse operation of squaring is taking the square root. So we're going to take the square root of both sides. Leaving me with x equals the square root of 12. But that can be simplified. The square root of 12, if I think about it, what are my options for multiplication? I have 6 times 2 and 4 times 3. Well, which one of these pairs has a perfect square? Not 6 times 2. 4 times 3, though, does. So 4 and 3. So my final answer is going to be 2 root 3. But I'm only half right. Remember, when solving roots, you have 2 answers, one positive, one negative. And yes, if you only put one, Alex will mark it wrong. In Alex, I don't believe there's this plus minus button, so you would do a positive 2 root 3, comma, a negative 2 root 3. So just to show what that looks like. I would write this as a positive 2 root 3, comma, negative 2 root 3. Just in case you forget why we need a plus minus here, let's just do another example. If I asked you to solve for x, if x squared equals 9, you would take the square root and you would say, oh yeah, square root of 9 is 3. And you're not wrong, because 3 squared equals 9. But so does negative 3 squared. Right? Negative 3 times negative 3 also equals 9. So your final answer here would be positive 3 and negative 3. Okay, that's going to show up several times in this unit, so keep an eye out on it. Keep an eye out for it. Number 7, quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So remember, this division applies to the entire numerator, and you need to check, does one side equal 0? If it doesn't, add and subtract to make that happen before you start. So what's a, b, and c? So remember, ax squared plus bx plus c. So here, a equals 2, b equals 7, and c equals negative 6. So let's go ahead and plug those values into our formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, from here on out, we're just using arithmetic to finish, but I would like to point out one trouble spot, and that is right here. Remember, this is minus whatever number this is. So if this number comes out to be negative, minus a minus becomes positive. And you'll see what I mean in a second. So this equals negative 7 plus or minus the square root of 49 minus 4 times 2 is 8 times negative 6 is negative 48. So don't lose track of that negative, otherwise it will come out wrong. And 2 times 2 is 4. Also notice I put 7 in parentheses, even though it's positive. This negative comes as part of our formula. So if b had been negative, 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 this would have become positive. Okay, so I'm going to make my next line down here for space. A weird equal sign. Negative 7 plus or minus the square root of 49 plus 48 all over 4. Negative 7 plus or minus. Perform that addition to get 97 all over 4. Okay, now Alex will take your answer in radical form, but you need to split it up. So my final answer that I would type in would be negative 7 plus root 97 all over 4, negative 7 minus the square root of 97 all over 4. And that's my final answer. Okay, so there is numbers 1 through 7 of the Unit 5 assignment. If you would like to now go into ALEKS and try numbers 1 through 7. Have a great day.